Deep in the bamboo forests of southern China, something enormous moves through the trees. Not a bear, not an elephant, an ape. Standing close to 3 meters tall, weighing over 250 kilograms, and staring back at you with the quiet intelligence of a primate. This wasn't a monster. It was real. And until roughly 250,000 years ago, it walked the same earth we do now. Gigantopithecus blacki is the largest primate that has ever lived. We know it from around 2,000 fossilized teeth and just 4 jaw bones. Enough to reconstruct its diet, its size, and its relationship to us. Its nearest living relative is the orangutan. Its teeth show thick enamel built for grinding fibrous vegetation and fruit. Its jaw was massive, anchored by a pronounced sagittal crest, the ridge of bone that powers the muscles needed to crush tough plant matter. But here's the question. What would it look like if it had survived? Not as a cryptid, not as Bigfoot, but as a real, breathing animal living today. That's what we're going to find out. Any realistic surviving Gigantopithecus must satisfy 3 constraints. First, it stays enormous. Bulk, deep jaw, sheer physical presence. Second, it has to be ecologically viable. An animal this size needs massive caloric input and a habitat that supports it. Third, it has to explain the legends. Yeti, Yeren, Bigfoot. These stories didn't come from nothing. A surviving Gigantopithecus needs traits that could generate centuries of sightings without leaving confirmed physical evidence. To understand how it could have survived, we need to understand why it didn't. A 2024 study in Nature gave us something precise. An international team analyzed 22 cave sites across southern China, combining pollen records, sediment cores, and isotopic signatures in fossil teeth to reconstruct the exact environments Gigantopithecus inhabited. The extinction window fell between 295,000 and 215,000 years ago. What the study found wasn't simply the forest shrank. Gigantopithecus was fatally specialized. Its diet built around forest fruit. When increased seasonality disrupted plant communities, it couldn't adapt. Its close relative, the Chinese orangutan Pongo weidenreichii, shifted its dietary habits and survived. Gigantopithecus showed signs of chronic stress and dwindling numbers. It ran out of options. That failure tells us exactly what a surviving lineage would need to change: dietary flexibility, expanded habitat range, and a lower caloric requirement per unit of body mass. The animal that survived the Pleistocene bottleneck would not be the same animal as the one that went extinct. The surviving lineage doesn't stay in the lowland forest. That's the habitat that failed them. Selection pressure pushes a subpopulation upward into the montane forests of the eastern Himalayas and the Hengduan Mountains of southwestern China. Montane forest is far more stable across glacial cycles. Vegetation shifts with altitude rather than disappearing. The environment selects for cold tolerance, thicker coat, denser fat deposits, a more compact body plan. Fruit is seasonal at altitude, so dietary adaptation becomes urgent. Over tens of thousands of generations, the lineage develops what the extinct Gigantopithecus lacked: metabolic flexibility. The gut elongates. The animal learns to extract nutrition from bark, lichens, bamboo shoots, and roots. The same evolutionary solution reached independently by mountain gorillas and giant pandas. It also becomes opportunistically omnivorous. Eggs, small mammals, carrion. Not a predator, but no longer exclusively herbivorous. Body size adjusts. The surviving lineage stabilizes at 200 to 230 kilograms and around 2.4 meters upright. Still the largest primate alive by a wide margin. Locomotion shifts too. The original Gigantopithecus almost certainly moved on all 4s, knuckle walking like a gorilla. Montane terrain, steep slopes, unstable scree, narrow ridge lines, favors versatility. The surviving lineage develops sustained bipedal movement across open ground, reverting to quadrupedal locomotion in dense forest. This is the adaptation that generates human-like footprints at altitude. Not supernatural, biomechanical. The coat runs from dark reddish-brown to near black, with older males developing graying across the face and shoulders. The deep jaw is retained, reinforced for tough montane vegetation. Cognitively, this animal is sophisticated. It uses stones to break frozen ground, constructs seasonal sleeping platforms, and maintains a complex vocal repertoire of long-distance calls across mountain valleys. Population density is extremely low. A surviving lineage would likely number between 800 and 2,000 individuals across eastern Nepal, Bhutan, the margins of the Tibetan Plateau, and the mountain forests of Yunnan and Sichuan. A critically endangered animal by any measure. The Yeti is not a myth pulled from nowhere. Across Sherpa, Tibetan, and Nepali traditions, accounts of the Mogoi share consistent details: enormous size, bipedal movement, a distinctive smell, and intelligence that sets it apart from bears. These descriptions cluster in exactly the altitude band where montane forest meets tree line, precisely where a surviving Gigantopithecus would be most active. The absence of a confirmed body deserves a serious answer. Fewer than 2,000 individuals across several 100,000 square kilometers of high-altitude terrain. That is the expected density of an animal that leaves almost no trace. We searched for the Javan rhinoceros with dedicated teams for decades before confirming its survival. Absence of confirmed evidence is not evidence of absence. It is the predicted outcome for an intelligent, low-density animal in terrain almost no humans enter. Gigantopithecus blacki went extinct because it was too specialized for a world that changed too fast. The version that survived, leaner, more flexible, more capable, would be one of the most extraordinary animals alive today. A primate larger than any living ape, navigating glacial terrain, leaving footprints in the snow, calling across valleys that very few humans have ever entered. Whether something like this still exists is a question that remains genuinely open. What we can say with confidence is that it's not biologically impossible, and for now, that is more than enough.